This is Note Taking Guide 2.2 for Math 2 class. We're going to talk about complex numbers today. So there's two rules that you really need to know, and these are them. You just really need to memorize them and live by them. Anytime you see the -1 underneath a square root, we're going to call it the letter I. Now, some might think that that's kind of weird, but I want to remind you that we use symbols all the time to represent other numbers, like we use pi to represent the number 3.14. So that's what we're doing here, is we're just using a letter to represent a value for a number. So every time we see a negative underneath the square root, we're going to call it the letter I. And then every time we get an I squared, we're going to know that that's equal to -1. So let's see if we can solve these problems the same way we did yesterday. Yesterday we showed you how to do this by hand and then told you that you could totally just do those on the calculator. So if you were to put the square root of -36 on your calculator, it would give you a domain error. The reason it has that domain error is because of this negative right here. But if we rewrote this square root as the square root of 36 times the square root of -1, then I can do this part on my calculator. It will come out as 6. And then if we remember that rule about what I is equal to the square root of -1. So we know that this part right here becomes the I. So my answer is actually 6I. On this next problem, again, same thing. We're going to just let our calculator do the square root for us. Or you could do it by hand. You could come over and do 132 is 2 times 66, which is 2 times 33. So you have a set of 2's that can come out, and 33 is going to stay in. That negative is going to be represented by the I, again, because we could write that as 132 square rooted times the square root of -1. The -1 right here becomes the I, and then over here we're going to come back and look at this. Our group of 2 gets to come out of the square root, and we'll have 33 underneath the square root. So our answer would be this. Sometimes I like to write my I right here instead of on the end. That way you can tell for sure that it's not underneath the radical. All right, example 3 right here. When we do radicals like this that are fractions, it's easier to separate them, because if we separate them, then our calculator can do them one at a time. This negative over here we know is going to be square root of -1 here, so we're going to add that one as an I in just a minute. So I'm going to write I down here for my answer. I'm going to square root the top, which is going to be 4. And then I'm going to square root the bottom, which is going to be 8. So I would have 4 over 8I, but this right here will reduce to 1/2. So my answer is 1/2 I. All right, this next one right here, you have the square root of 148 that we're just going to do the same way that we did yesterday. We're going to grab this number right here and let our calculator do the work. When we let the calculator do the work on this, we get 2 square roots of 37. So 2, I'm going to leave a little bit of space in between the 2 and the square root of 30. I said 37 and I wrote 33, sorry about that. So 2 square roots of 37. That negative is going to come out as an I, so you can put it in there wherever you want it to go. And then we're going to talk about our variables. We have 3 A's here. We have to have a group of 2 to bring out. So 1 A gets to come out. 1 A has to stay under. We have 4 B's. They come out in groups of 2. So we have 2 groups of 2. So we're going to have B squared that gets to come out. So this is really messy looking. It actually looks worse than it started out, but this is the simplified version of this. That I right there could be thrown anywhere in here, or you could throw it back behind as long as it's not underneath the radical. All right, again, this would be like the square root of -1 times the square root of x to the 5th. So this we know is going to give us an I on our answer. And then we're going to talk about how many x's we can bring out. Well, how many groups of 2 are in 5? You can go 2, 4. So that would be 2 groups of 2. And then we would have 1 left over underneath there. So you could write it like this. I think it kind of looks funny with the I off the back sometimes though. So again, that's why I like to write it out front. before I write my radical, but either way this one kind of looks silly. Okay, right at the top of our note-taking guide, we told you a rule that said I squared is equal to -1. So every time I see an I squared, I'm going to change that value to -1. So this is the distributive property. I'm going to multiply that through. I get I times I, which is I squared. And then I get I times 5, which is 5I. I squared is a -1, so I'd have -1 plus 5I for my answer. I can't simplify that any further, so that's where I'm done. This is also a multiply problem. -5 times 5 is a -25, and then I times I is I squared. So this will be -25, and then I'll replace that I squared with a -1. Because there is no symbol between there, that's implied multiplication. So I'm going to multiply the -25 times the -1 to get +25. So a point I'd like to bring out right here is every time I see an I squared, I just change the sign on the front of the number and drop the I squared off. That's kind of the way I like to think about it. This is actually subtraction. When we subtract imaginary numbers, we're going to treat the i's like it's a variable. So if we have exactly the same variable, we can just combine them together. So 2 minus 8 would be a -6, and we're going to throw our I back on and just leave it there. Thank you for watching this note-taking guide.